not find any process where uh, there is no measurement system variation. So we want to ensure that whether the measurement system variation is within limit or not. And we also looked at certain parameters for that or certain numbers for that. And we compare them with a red, orange and green signal. So if in any measurement system, if the variation is less than 10, you can go ahead with a green signal. If it is between 10 to 30%, you have to take a call from your champion or a process owner. And if it is more than 30%, even your champion cannot override this. So you have to stop. Like we compared in our day-to-day situation, like green signal, orange signal, and red signal. So if it is more than 30, it is a red signal. You cannot proceed at the signal. If it is 10 to 30, it is an orange signal. Sometimes you can take a call. Sometimes, as you say, orange signal, you can go also and you can stop also, like that. And if it is less than 10, you can go ahead. Then we looked at the capability of the process. So what is a capability or a present capability when we are at baseline level? So the idea is to improve that metric. So we want to understand what is my present capability on the scale of 0 to 6. So any process, it may be a cycle time, it may be a yield. What is the best advantage of having a Six Sigma methodology is that we bring that on a scale of 0 to 6 to compare with one another, so that you can compare apple with mango, a Kaliangad or watermelon, etc. So that all your processes are on the scale of 0 to 6. That is what is an biggest the the best way Jack Welch used during a GE. He brought all his businesses on the scale of 0 to 6, and then working on the businesses which were not performing to his expectations, or rather where the sigma level was low, and improved them slowly. So we have to prioritize where to improve. So it is not like that where the sigma level is already 4, you try to improve that, because there is a lot of effort which is going inside, and you will achieve not achieve much with the expectation of the customer. Then after fixing or after closing all that on the Y side, we went on the right side to understand what are the potential causes for this. So the idea in Six Sigma is always improve a process or a system. So that my Y will automatically come. And my whole intention is to control excess. So I want to understand which excess are making impact. And we in a Six Sigma will call them as a potential excess. So we looked at an various tool. We looked at an process mapping. So looking at that process mapping, we can understand also how the potential excess can be identified. And once you know the potential excess, then the next step would be to screen those excess in an analyze phase. So last time we looked at basic quality tools, or also looked at a new 7 QC tools, which out of which we have only selected one, that is tree analysis, and also looked at YY analysis. And from that we proceed today. We'll look at how FMEA works. Then we'll also look at the lean tools, and then the idea is to screen the potential excess to identify a vital excess. So let us move ahead. So what we have looked earlier was YY analysis. The next tool is a box plot. So box plot is very useful to compare 2 or more number of data sets. So how does the box plot look like? You must have seen the box plot like this. So why it is called as a box plot? Because it is a presentation of a data in form of a box. So the box looks like this. So when the upper part of the box, which is there, Okay, so upper part of the box, which is called as an Q3 or a 75th percentile. You very well understand what is 75th percentile and 25th percentile now. And the middle one, which is called as an Q2 or a median. So 50th percentile. So this is what is a box. If the box is very symmetrical, then you can say the process is uniformly distributed and it is normal. Now, in this case, what is happening? Your mean is different than median. That clearly indicates your process is not normal. So it is from a box plot, you can understand that also whether my process is normal or not. Then there is another lines which is called as an whiskers. So how does the whisker go? So the length of the whisker is 1.5 times the interquartile distance. So what is interquartile distance? It is Q3 minus Q1 into 1.5. Now you can look at on the upper side, the whisker is short, while on the lower side, the whisker is long. So how this can happen? This will happen only because the whisker, it may happen that the actual length of the whisker is coming up to 90. Okay, so let us say example, this point, this should be 90, but there is no point in the data set which is more than 75. So whisker will cut at 75. That is what is the meaning of this. That is why the whisker is short. Now, if there is a point beyond that whisker which is called as an outlier in the process. So when you are analyzing any data, it is very important to understand why there is an outlier in the process. Because what happens, this outlier generally impacts your mean. Okay, so if there are 2-3 outliers, so the first point is to understand the reasons for those outliers. And even if you could able to chop out those outliers, you will improve the average and your process will improve. That is how you have to go as a first step. That is what is called as a low hanging fruits in Six Sigma. So so if you look at this box plot, you can understand whether my data is normal or not. If it is not normal, then it is skewed one. So my mean and median are not same. And you can also understand that there are outliers. So how many outliers are there, and what are the reasons? Suppose on particular day yield is coming low, so there will be 3-4 days like 4th of April or 4th of March, 13th of March, and 24th of March. So those are the outliers. Then you can go at that day and identify using brainstorming or various other tools why it was low, and then plug those reasons so that the outlier will not arrive. And if the outlier is not there, then your process will improve. That is how this box plot analysis works. Now, how can we use that? We can also use this to compare the different data sets. Now, if you look at it is a particular operation which is being done by various operators in our organization. So it is a box plot of various operators, that is Ashok, Balkrishna, Madan, Gajanan, Sachin, Krishna, Shankar. So what is this? This is a cycle time of any activity. So you will be able to understand that Madan and Gajanan has a problem in doing this job, and there's a lot of variation in it. So if you want to improve the cycle time for a process, you would like to understand why Madan and Gajanan is having a longer cycle time on some cases. Is it a problem by parts, or particular part Madan has or Gajanan has a difficulty in understanding a particular type of operation or something like that? Then you can also understand why Sachin is able to score even a lowest one, sometimes 2, even 2. So what is good, that you have to again look at the process, and what is bad, you have to understand why it is going wrong, and then find out the reasons. It is basically observations at shop floor that will give you the clues, and if you are able to improve the variation of Madan and Gajanan, you will be improving the process. That is how it can be done. So another example, which is done at the end of a project, I have been repeatedly saying that your process has to statistically different than your baseline. So you have to improve your process statistically. So probably you can look at this. We compare a box plots of baseline data versus improved data. So it is a lower the better function. That is something UV glow. And when we have taken up this project in September to November 11, the figures were like this. And when we have improved the process in March to June 12, the average was like this. So even with an visual, you can understand that this box plot is different than this box plot. Means probably this is not an final word or making a call that you have improved the process. For that, we do an hypothesis testing. But from this, you have an idea that yes, my process has improved. Now, if these two boxes are overlapping on each other, probably you yourself will conclude that yes, there is a lot of overlapping, and I cannot predict after improving the process that I have really improved the process. So, so you cannot claim that I have improved the process and my project is complete. That is how it goes out. So this is about the box plot. And then the next tool is very important tool as far as the chemical engineers or the process industry is concerned. So the tool is called as a correlation regression analysis. So basically it is a correlation analysis, and based on this correlation, a regression or a regression equation is developed. So basically it is done for an continuous y and continuous x's. So dependent variable is continuous and independent variable is also continuous. What is dependent variable? Y. Y is called as a dependent variable. So in our equation, y is equal to f x1, x2, x3. So y is depending on certain x's. So x is called as an independent variable and y is called as a dependent variable. Both of them are continuous. So what I mean by continuous, it is a ratio scale data, means temperature, kg, centimeter, etc., etc. So let us look at how correlation analysis works. So we have seen this graph of x versus y. So when we were looking at 7 QC tools, we had an glance view of these graphs. So what is first graph, which is in left top corner, indicates if we increase x, my y is increasing. So they are directly proportional in mathematical language. The second is, this is what is called as a positive relationship. So if I increase x, y will increase. This is what is a positive relationship, perfect positive relationship. And the second graph is about a negative relationship. If I increase x, my y decreases. So this is also a perfect negative relationship. And if you look at the other graphs, they are showing some type of a relationship. This is also a relationship. This is also a relationship. This is a curvilinear relationship, etc. But more often, this is what is an subjective analysis or visual inference from the graphs. So is there any mathematical method? So the method is called as a correlation analysis. So it is also called as a Pearson correlation coefficient. So mathematically, so Pearson correlation coefficient varies from -1 to +1. Okay, so based on if you have a data set of X, temperature and yield, or temperature and pressure, something like that. So if you want to find out a correlation between that X and Y, probably we always say iska aur uska jamta hai, they have a good relationship. But that is a subjective term, good relationship. Now what we in Six Sigma want to do, we want to convert that into a mathematics. So unless it is represented into number, we can't say what is an exactly strength of that relationship. So that relationship, what we have seen on the graph earlier, we are converting that into a mathematical presentation or a strength of relationship. So the strength of relationship is always presented in a form of a coefficient correlation, which is from -1 to +1. So when it is -1, it implies a strong negative correlation. As it goes towards 0, it does not show any correlation. And if it goes towards the +1, it implies a strong positive relationship. So we calculate that, which is what is called as an R. Now let us look at as an example how it is being calculated. So I want to analyze some problem in my continuous process. So the problem in a continuous process is generally the interruptions in the process. So we call it as a break pattern. So I go to a process flow map, identify there are 3 steps in a continuous polymerization. I have written CP here. So the long form of this is continuous polymerization. So in a continuous polymerization, there is a first step which is called as a continuous polymerization, then spinning and then winding. So what are the different steps which are involved in continuous polymerization? Probably slurry preparation, esterification, oligomer, flasher, etc. These are the steps. Then the next, what I do, I take out all the parameters, what we set as in process parameters for correlation analysis. And it will be a laundry list, just as a sample format. So what is my slurry density, what is my mole ratio, what is my reactor level, what is my reactor process temperature, etc., etc., etc. And then with my output, that is breaks. So if you look at this, the correlation analysis of CP parameters with respect to breaks, I have selected 55 parameters. So all those 55 parameters has been selected, and they have been the relation have been identified with respect to the breaks. So at a time, so this is what is a representation. What is a representation? It is an so R is a coefficient of correlation. That means it is minus 0.063, and there is a p-value also. So wherever the p-value is less than 0.05, that parameter is significant for my breaks. So that is how, what is being done using a statistical software called Minitab. So once you understand that, it is very easy for you to understand or change that parameter based on the what is the sign of this. Now when I say the correlation coefficient is minus, what does it mean? The coefficient correlation is minus if I want to reduce my breaks, I need to increase my throughput. Okay, so means my Y is lower the better. That is why I have to increase my X. As I increase my X, because this relationship is my negative, as I increase my X, my Y will get reduced. This is about the one of the parameter which is throughput. So let us look at the process parameters. The reactor level, this is again minus. The reactor process temperature, which is again minus. If your p-value is less than 0.05, it is called as insignificant. When if it is not less than 0.05, we call it is not important. So from very easy to identify which are the parameters which are playing role in decreasing something or increasing something depending on the relationship or what we are looking for. So actually for a process engineer, as when you join any organization, you will find always there will be a variations in the process, but it is very important to understand that are these variations in the process are making significant difference on your Y, and how you can do it. You can do it only using a correlation analysis. Otherwise, my gut feeling, my process knowledge is all good, but it is better to verify that using a statistics whether the process knowledge what you have is really fitting the statistical knowledge or statistics or not. So this is how it is being done. And once you understand those parameters, it is simply you can go and choose those parameters. Like what we have done, there were 55 parameters which were shortlisted. 55 out of 55, 32 were shortlisted. And now it may also happen they are that interrelated. Those X's also are interrelated to each other. Like the first X was throughput. So if suppose I increase my throughput, naturally the temperature is also going to increase, etc., etc. So those unidirectional problems or parameters were removed, and we have identified only 6 parameters which are very important. And once we adjust those 6 parameters, your process will improve. That is how it has to be done. That is very from an various points you come to an top 5 or top 6 which are really critical for your process, and you fine tune those to get an improvement in your process. That is how it is being done. So that is what is about when your Y is continuous and X is continuous. We do correlation and regression analysis. Going forward, if suppose we get 6, 3 or some parameters, we can write down a regression equation on that and identify how much X to increase or how much X to reduce to get certain number of Y, like that. Now, if there are various other tools also which are being used. If my dependent variable is discrete and independent variable is continuous, we use binary logistic regression. Or if both are discrete, then contingent. If dependent variable is continuous and independent variable is discrete, then ANOVA, like that. I'm not going to cover all these tools, but I just wanted to give you a flavor of one of these advanced tools, that is a correlation analysis, and which is very important for you, or rather bread and butter for your career, to understand that what is the correlation between the two parameters. Okay, so the next tool is a failure mode effect analysis. Now, the failure mode effect analysis is generally done. It comes from an automotive industry or equipments, etc. So, as we all know, the first step is what is process. So, if I want to conduct an FMEA for any so the first thing is what are the inputs for those process. So, detailed process map. You have seen this detailed process map, or cause and effect matrix. So you can use those reasons as an input for basically what are the inputs for FMEA? The inputs for FMEA are your potential X's, and from that you screen those potential X's using FMEA on certain criteria to identify what are your vital X's. So basically there are 3 types of FMEA which are being done: equipment FMEA, process FMEA, and design FMEA. So generally there are companies, as I said earlier, there is no right way or a wrong way in this. So the way organization perceived. So Ford Motor Company is one of the example of using an FMEA extensively. So they don't believe on any other methodology rather than, but religiously using an FMEA is very important. So for that, what they have done, they have divided this tool of FMEA in 3 categories. They call it as a process FMEA, equipment FMEA, and design FMEA. So process FMEA is simple. For any process, you identify a potential reasons and then work on that to identify what are the vital ones. We'll understand how they screen them by giving some rating, etc. The second is equipment. So what are the various reasons for failure of an equipment? And thirdly, if you are going for some design, so you are designing some new automotive. So what can be our new washing machine or new air conditioner? So you can brainstorm and understand how it can fail, how a component can fail, or then have a numbering on that. That is what is called as a design FMEA. So origination of this FMEA has started from a design, because the FMEA tool got very popular in US aerospace industry with the failure of an Apollo 11. So when Apollo 11 was a failure, the whole failure was analyzed using an FMEA, and thereafter, whatever aerospace yarns were sent outside, the FMEA was conducted to understand at a design stage to understand that how the equipment can fail and what can be a mitigation plan for that equipment failure. Now, if you buy nowadays, if you buy any equipment from US or UK, you will find always the consignment comes in a box, and you will always find an FMEA stitched on that box. So, so it is very important to understand that how the equipment can fail and what is the mitigation plan suggested by a vendor or a design who has designed this equipment, and then act on this. So how the FMEA works? So let us understand using a faulty method. So we have already seen that is what we have seen earlier is a process map and cause and effect matrix. So let us understand how fault tree works. So if suppose I am talking about a loss of pressure. So why loss of pressure? So loss of pressure can be, there can be 4 reasons. So primarily failure, power failure, combustion, fuel and air. So why power failure? Then there can be a reasons for that. Why combustion? Improper combustion. You can say burner. So what is in burner? What can go wrong with the burner, and what is improper soot blowing? So the reasons are again listed down. So this is what is called as an potential reasons using a fault tree method. Means why? What are the various excess for that? So this is your top why. You ask why, then there are four excess for this. And again you ask why, and you identify excess for that. That is how you identified 58 excess. Okay, so all those 58 excess are taken up to the next level. For all these 58 excess are taken up to the next level for rating for 3 things. That is, what is the severity, occurrence and detection. Okay, so what is severity? So severity is an impact of failure. So if my pressure goes wrong, so the problem what we were discussing was about the pressure. Okay, so loss in Dow pressure. So if my pressure goes low, what will happen? So the effect, if my pressure goes low, as felt by my customer or as defined by my customer. So it is not like that. So the customer who is a recipient of that process should understand or should be able to tell about what is the impact of that. And based on that, the numbering is given, which is on scale of 1 to 10. So the severity is assessment of seriousness or impact of the process for. Okay, then there is an occurrence. So how frequently the failure is occurring. So how many times this has happened? What is the probability of the event or a likelihood of the occurrence of the event? And the third point is a detectability. Yeah, am I able to detect that? So you can take it like that. Suppose you are reaching a college late. That has been your regular problem. Now, so if you have various excess, so the impact is if you are reaching a college late, the severity remains same, because ultimately what is the result of not reaching of the college by various reasons is going to be the same. So your severity is same. So severity assessed by the customer. Okay, so the severity is given by a customer on the scale of 1 to 10. Now, how frequently is this happening? So is it happening reaching college late is happening once in 10 days, once in a week, once in month, once in 3 months, etc., etc., is an occurrence. And what is the probability of detecting that failure? Now, if suppose that is what is an existing process control, what is the existing process control on this? So if you are reaching college late, are you able to understand that in advance that I am going to reach college late when you start or when you wake up in the morning? So you have that proactive mechanism to give you signals that this is going to fail. So if it is giving you a signal that I am going to reach college late, then probably your detection is, you have a good process to detecting it, you will number that less. And if you are uncertain of detecting it, then the detection rating will be high. Now suppose, suppose you want to travel from your place to college, and you probably go by car or a bike, something like that. And looking at the Google map, you understand that there is a traffic jam in this. Now, in earlier days, when there was no Google map, probably your detection rating was high because you were uncertain. You started at 10 o'clock with the expectation that you will reach your college by 11 o'clock. But unfortunately, you were not able to detect that there is a traffic jam. So probably the detection rating was high. Nowadays, you have an Google Map available for you, and probably you can look at a Google Map at 9:30 and look that there is a traffic jam in the midway from my place to college. So I have to start early, and you can predict that. Then your detection rating comes low because you have a process to detect what is going to be there. So that is what is the meaning of a detection. The detection scales, the numbering or the marks what we give for a detection slightly goes ulta. If you are sure about detecting it, then you give less, and if you are not sure about detecting in that, you give more. That is how detection scale works. So once we know that, we give a severity rating. Now there are various scales which are being given. AIAG, that is American group of automotive companies, gives a standard guideline for how to rate the severity, occurrence and detection. So this is how is in English. The same can be converted into numbers. How much is the loss? So if my loss is this much, then I give 1. If my loss is this much, then I can give 10, like that. So it is better to convert that into a number rather than having it on a subjective basis. So we have converted that into a number, but again, it will change from industry to industry. So from site to site. So if we have a big industry, then these numbers will also change. So you can set up that severity scale depending on the organization and like that. Now occurrence is again, bad is more than once per day, you rate 10. As your occurrence goes down, once in 3 to 6 months, probably you rate it as in 2, etc. So this is absolutely a probability on historical data that how many times this event has happened out of how many total events, like that. That is how occurrence is going on. Now the third is detection. If you are absolutely uncertain, then you will 10. And if you become certain, then you can reduce that score and probably give 1, etc. So 0 rank is not available here. You have to rank from 1 to 10. Now the product of severity, occurrence and detection is called as an RPN number. That is called as a risk priority number. So the risk priority number is a multiplication of severity, occurrence and detection. So as your risk priority number is high, ultimately either the impact of that cause is high or occurrence of that cause is high, or the detection is also not possible. That is why the number is high. So you can put them in a descending order, and you can start working from a top. That is how you can identify a vital excess from an potential excess. That is how it is being done in FMEA. And for every cause, then you have to have an action plan, mitigation plan, or avoid reoccurrence of the event. So there is one approach looking at only RPN number, but there is another approach, as I have shown you in on a slide, that for a failure mode A, the severity is 10, and the occurrence is rare, detection is also good. So if the event is happening, there is a lot bigger impact for this. So it is again a guideline from an organization. Some few organizations also decides that high RPN number and severity rating more than 7. Okay, so the event is rarely to happen, like flood, etc. But if it happens, the impact is going to be tremendous or very large. So that is how also you can screen this based on the RPN number. This is how FMEA works. So when we have a high RPN number for any failure mode or any reason, this is what is an earlier RPN number, which is a product of an severity, occurrence, and detectability. Now, generally, the severity remains for every cause same, because the impact on the customer will always remain same. Okay, so the severity remains same. What you can work in the process is to reduce the occurrence or improve the detectability. So this is how, after the action, again, the severity, occurrence, and detectability is measured, and you can see the RPN number for a particular project is reduced from 336 to 60, or 336 to 72, 210 to 24, like that. So this is how it is being done in a project. So what do? You identify potential excess. All those potential excess are rated for severity, occurrence, and detectability. Potential excess is nothing but the causes. And wherever the RPN number is high, you take them for an action, because those becomes your vital excess, and improve them so that your RPN comes down. As you see, there is a relation between this X and your Y. The Y automatically will improve as you have a mitigation plan in place to improve or to reduce the occurrence of a failure mode. So this is how FMEA works. So moving to a lean tools. So this is about generally called as an quality tools. So we'll now move to the lean tools. There are various lean tools also which are being used in the process. So lean is a systematic approach of identifying and eliminating a waste. So you can look at a person who is a fat. Now from fat he goes thin. The lean, the meaning of the dictionary meaning of the lean is also a thin person, a freshly person who is swift. So there are various tools which are being used in lean. Is value stream mapping, then identification of 7 types of waste, or there is also 8 type of waste, then 5UAS, POCA, OK, spaghetti diagrams. Now, when you are using these lean tools, there is not just statistics or mathematics is involved in this. Generally these lean tools are based on a common sense or actual observations at the shop floor or data collection, etc., etc., looking at a process with a different perspective, etc. If you look at those quality tools, there is some kind of a statistics which is involved, which when in a quantitative tools, where qualitative tools, they are generally for identifying the potential excess. But if you look at these lean tools, they are based on the understanding or common sense. So you will also look at an evaluation of the lean. So probably lean as an concept which came into structure in 2000 by Toyota manufacturing industry, but it is being used from earlier 1850 or rather I think 1900, where the very important tool which is known to all of us, which is called as a time and motion study, which was evolved by Frederick Taylor. So the lean is about a time and motion study. So every time if you look at a lean, you will always talk about how much is the cycle time for that each work and what is the frequency of the work. And then based on that, you can also actually calculate how much is the occupancy of an individual person working at the organization, etc. And basic concept of time and motion study, in which was evolved in 1900, was fine-tuned by various people like Henry Ford, Toyota, etc., etc., to have a very sophisticated concept like a lean manufacturing process, which is actually being practiced at Toyota. So there was a makeover after the Second World War at Toyota using all these lean concepts. And those lean concepts were introduced at Japanese industry by two gentlemen, those who are American, Edward Deming and Joseph Juran. Actually, Deming and Juran both are American, but they are more popular in Japan, rather than US. So the Japanese government also gives away prize by these two gentlemen. They say it as a Deming Award or Juran Award, etc. So they are highly recognized in Japan. So so basically, starting from time and motion study, it moved ahead slowly. And the first change which was brought in by Henry Ford, the Henry Ford is called as a father of mass production. And he also looked at the various waste reduction, that is reworking, reusing, remelting, or converting paper rags or hardboards into binder boards. Means we have a concept of recycle, reuse, etc. So Henry Ford thought about all those concepts in year 1950, etc. Even before that. Okay. So so he had a lot of accomplishments in his life. The main was the concept of an assembly line. So you must be knowing there is a concept which is used in automotive industry, which is called as an assembly line. Now this concept is very well popular all across the retail, etc. But the concept was introduced by Henry Ford first time in a Ford Motor Company. Then he also talked about backward integration of the processes or backward integration of the material. So as we all know, Ford was a motor company. While going through a backward integration, he also set up a steel mills to produce steel, then glass factory, then also rubber plantation at Brazil to get the rubber for their car manufacturing, and also own their ships to carry the ore from various ores to a factory like that. So this is how he has introduced a backward integration for the first time in the world. Dhirubhai Ambani also worked on the same concept in a chemical industry, where he started from a polyester industry, then went back to fiber intermediates, that is what is called as terephthalic acid and MEG. And for that MEG, he went back again to produce different chemicals and then to refinery and like that. So I feel always that Dhirubhai Ambani is inspired from Henry Ford. Okay, so basically the lean manufacturing is based on three pillars. That is very commonly used in Toyota production system. They call it as a TPS or manufacturing system also. So the three pillars are Jidoka, Hijunka, and just in time. So these are again Japanese words. For the Japanese words, what is the meaning of those Japanese words is also written here. So basically, Jidoka means automation. So automate the process, avoid human intervention, built-in quality. So the product by process. So the quality should be built in as a process. So when we were talking at the introduction phase, I always give an example of an Dabbawalas in Mumbai. So Dabbawal, what is the secret of an operating such process at such a high level? Their sigma level is more than 6. They are now operating at, it is said that 9 sigma. That means 99.9999% perfection. So they are all illiterate. They can't speak any language other than Marathi. But even though they are producing the results which are of a perfect process. So what is the process in that? The process is important. So it is important to understand a perfect process. That is what is the meaning of a built-in quality. And stopping at abnormalities. So set right the things and don't allow abnormalities to pass to a next process. Just make them correct and then give it to the next process. That is what is meaning of an stopping at an abnormalities. That is how one of the pillar is Jidoka. Then the Hijunga is about load leveling or sequencing or standardized work. So load leveling is basically how we distribute our work. There are series of processes in a sequence. So in a sequence, the E is the output of an A and B and C are batching so that there will be an uniform flow of an output. That is what is being said as a level loading. Then the concept of an just in time means optimum piece flow. So how much is an optimum piece flow? So that is very important to understand that we have to have an optimum piece flow and it should be within drum beat, rhythmically going forward, and we match the output of all the intermediate steps so that we get an smooth production every hour. That is what is the cost called as a concept of an tuck time. So what is the tuck time? And this tuck time is called basically a customer want time. So how much the customer wants. So if suppose the customer wants 100 Ertigas to be produced at Maruti plant, your process has to be designed like that you should be able to give 100 Ertigas in a day. So based on that 100 Ertigas in a day, so how many in an hour and how many in a day? So how much time is taken to produce one Ertiga, that is going one Ertiga out, that is what is called as tuck time. And that has to be rhythmic. It is not like that when we are coming to a duty, the output is 5, and when we are again having a lunch, the output is 2. It is not like that. It should be in a rhythmic manner. It should be a continuous flow, and continuous product per hour should remain constant for throughout the 24 hours. And it should be adjusted as a pull of a production. Means what the customer wants. Pull means what is customer wanted by a customer. You have to adjust your process, or you have to design your processes based on the need of a customer, not as a push on the production. So there are two concepts which are being generally called in lean, which is push in the process and pull in the process. So when you are pushing, the A process is pushing B, means producing and pushing it to B. Then B is pushing it to C. Otherwise, what is important in lean production is pulling from the process. So what is your end step process is pulling the product from the earlier process. So it should be on that concept. That is how you have to design a process. That is, has been emphasized in lean production system. Okay. So Toyota production system is a very good example of a lean production system. Then it also talks about the SMED, that is single minute exchange of die or change over time between your products. So earlier, if in our young days, there used to be only two products like Fiat and Ambassador. Now you all know there are a lot of models which are available in the market, and a lot of companies are there and lot of products are there. So if you look at only Maruti Suzuki or Ford or Kia, there will be a lot of products. So how the Maruti is able to change from one product to another product is also important, and that time has to be minimum. If that time is minimum, you save means you save your time, so that your productivity goes up. Once your productivity goes up, all your overhead expenses goes down and cost of production goes down, so that you gain on margins and your business becomes more effective or more why means you gain more money from the process. That is how it is being done. So basically, you have to work smart. That is what is called as a lean process. So reduce waste. So we talked about the value earlier. So the task must physically change the information or the product. So movement does not add any value. So how you can add value in a process? By physically changing or moving the product. Then customer must think that this task is important, and the task must be done right first time. Means these are what is called as an hidden factories. So many of the times what happens in our organization, we at station 1, we do something, and we realize at station 2 that this is not being done correct, and we resend it to 1 and rework on that. So that is not is accepted in a lean concept. So what is important is do it right first time. That is what is the concept of a lean. So the simple example, we always go to a doctor when we have a fever, etc., etc. So if you look at when we go to a doctor, what is a value added time and what is a non-value added time. So probably you will go to any dispensary, you will check in, sit there. If suppose there is a receptionist who is present there, he or she will check they will check whether you have a temperature, what is your weight, height, etc. Then some test preparation, they will actually do your testing, and then you consult to a doctor and then come out. Probably this time is only 26 minutes, and you spend almost 20 minutes in between. So the concept which is highlighted in lean is what is your value added time and what is your non-value added time. So this is a very common example when you visit a doctor or a hospital, or you undergo any medical checkup, etc. So the ratio is important. How much is a real value added time, and if it is more, then your process is more effective and you are adding value more in the process. That is how it is to be done. So basically, lean is for identification of a non-value added activities. So the main tool which is used, which is called as a value stream mapping. So how does the value stream mapping? We have earlier seen what is a process flow mapping. So in a process flow mapping, we have only identified the parameters and how the process moves. But when you are doing a value stream mapping, you are also adding various information to each and every step. Now, if you look at this, this is a process, or this is an industry, and in that industry, suppose you have various steps at each process. Now, if you look at this, there is a stamping, then welding, welding station 1, welding station 2, assembly, assembly 2, and then shipping. So general, don't take it seriously, but these are the general steps. Now, actually, how much cycle time is for stamping? So cycle time for stamping is just 1 second. The changeover time is 1 hour. And how much is an uptime of this equipment? And how, if you look at an timestamp of in each and every atom which is being produced for stamping, it takes only 1 second, but it stays in the queue for 5 days. So material has come, and which is in a queue for 5 days, and after that there is a stamping which is done in 1 second and goes for a second step. Now the second step is welding, which is welding 1, welding 2. So welding 1 is just 39 seconds but for that his turn to come, it is just waiting for 7.6 days in a process. So what we are trying to find out in this is what is the value added activity, or what is the processing time or actual production lead time. So production lead time is 23.6 days, out of which the processing time is only 188 seconds. So it is also important to understand how we can reduce this, or we can look at each and every aspect, that is what is an cycle time of an each event, what is an changeover time, what is an uptime of an equipment. Now if you look at an welding machine 1, the uptime is 100%, means there are no failures. But if you look at an welding machine 2, it is only available 80% times. That means we are unnecessarily losing time for 20%. So this is what is the value stream mapping is very important to understand the bottlenecks in the process. And it will give you, if you do this value stream mapping for one of the process, you will come to know what are the areas which need to be done, and based on that you can have what is, this is called as an as-is process. Okay, so what is being done at each step probably is what is the cycle time, how many defects are produced in that at that station, how much is the non-value added time, what is the changeover time, what is the uptime of an equipment, what is the inventory, how many pieces, and how many days of inventory. Like that, if you put that on a paper, you will realize and you will understand the bottlenecks in the process. The aim of an value stream mapping is to understand the bottlenecks in the process, and once you understand the bottlenecks in the process, you can take them for improvement. That is what is the purpose of a value stream mapping. So use the current state. Where current state, what is this? This is done for a current state. So as is basis or baseline basis. So use your current state value stream map to give direction to your future value stream. So once you do that current state value stream mapping, you will automatically understand that what needs to be done looking at your value stream mapping. And once you identify those bottlenecks, you can guide and you can design a future value stream process to focus your efforts. So you can ask various questions. What is the rate of demand? How much does the demand vary? How much should be the flexibility or buffer? How and where should you filter and level orders, etc. This is about a typical ordering process. Where and how can you combine operations to create a continuous flow, like that. So you keep on asking some simple questions based on these guidelines at each and every step so that you develop a future process map. Generally, it is based on five main categories, which is combining a process. Can we combine the process? There is always a scope in a transactional processes to look at this. So are we able to combine any process? Are we able to simplify a process? Uh, can we eliminate step? Can we have a new technology to eliminate the step? Or can we have a change in authority level for signing, etc.? So many of the time के सबके पास pending है, सबके पास pending है. So this is what is where the change in authority level is required, so that the person below one level can also sign, and the work can be done at a faster rate. So these are the five broad categories. If you ask, going forward, you can ask various questions: rearranging sequence or a work step, rearranging a physical location of an operator in the system, changing a work method, changing the type of equipment used in the process, redesign forms, documents, efficiency, improving the operator training, improving the supervision. So if you ask all these 10 questions, or what I have mentioned in these three earlier slides, probably will give you insights for a future state map. So once you have your current value state map, it is important, based on answering these 10 or 3-4 slide questions, to design a new process which is a future state map. So during that, we also do to identify what is waste in the process. So waste elimination always gives you an competitive advantage. So it has to be very simple and uh, uh, easy. So there are 8 types of waste which are being emphasized in lean. Earlier I said 7, but that time the intellect waste was not included in that. That is why I said there are 8 types of waste. So 8 types of waste, which is called as an work pit. Okay, so WORMPIT, worm pit. So we'll understand what is the meaning of an weight. There are other areas of waste is reprioritization, energy waste, and complexity in the processes. So due to unnecessary complexity in the process, we produce waste, means we lost decision making or wait sometime, etc., etc. That is what is being emphasized here. So let us look at the 8 types of waste. So waste of waiting, time for which material, people, machine waits unutilized. So if we balance the output of each and every step in the process, probably it will be a one-piece flow, and no process person, no individual at process 3 or process 4 don't have to wait for him to material to come from a process 2. That is what is the meaning of an waiting. So the example is person waiting for machine, machine waiting for a person. So there are lack of unavailability of the skilled person. So the skilled person will come and then the machine will start. So lack of concern of equipment breakdown. Equipment breakdown is also waiting. So the operating people are unnecessary waiting, as the mechanical people or maintenance people are working on the machine. Typically, if your car break down in between on a highway, so probably you wait that is a waste of time, and you are that is a productive time for an mechanic, but it is an unproductive time for a person who is waiting. Person waiting for an person, waiting for an information plan, waiting for approval, waiting for server program availability. Uh, so causes are inconsistent work method, unbalanced workloads, many handoffs, cross-sharing resources, lack of proper resources, reprioritization of works, etc. are the causes. This is what is called as an waiting. So overproduction. So generally producing more, which is not required by next process. So extra copies, extra files. You will say always such type of picture when you are traveling on the highway on the roadside. So there is no market demand for particular type of an vehicle, but that is being produced and then kept on roadside highways for waiting for a customer. That is what is called good example of an overproduction. If you want to make a 2 cup of tea, probably you will make every time some more, which is 2.2 or like that. That is a waste. That is what is called as an overproduction. Basically, which is not required by next production, next process, and means the next process is not capable of taking that. Basically, you can also call stomach and mouth. If you talk about an stomach and you eat more, that is an overproduction, which is not able to digest by your stomach. That is one good example of an overproduction. So the third type of waste is what are the manifestations of overproduction and what are the causes. So manifestations can be inventory, extra documents with your bills, extra resources, extra copies, extra storage for duplicate files, additional information just in case, installation of unneeded software, damaged goods due to multiple handling, etc. The causes is incapable process, lack of communication, lack of consistent schedules, focus on expectations, etc., etc. So we go. The third is defect or rework. So anytime if you produce a defect, then it is bad. It is a bad quality. So either that defect goes to a customer if it is not noticed by your organization, or it comes back for a rework. If it comes back for a rework, it is a loss of productivity. That is what is meant by this as a defect or rework. Sorry. Then fourth is waste of motion, looking for file information, excessive reaching bending, machine material too far apart from an work time, fatigue, confusing motion at work, etc. are the uh, various examples of emotion. When we generally when we call of an waste of motion, it is for an human activities, and when we call upon a transportation, it is for an goods or something like that. So when we talk about an waste of motion, it is about an activities, human activities. So equipment, office layouts are not properly placed, so somebody has to go from one place to another place, and which is very time consuming and unnecessary, creates a fatigue, which is a waste of motion. Inconsistent work methods is also an example of an motion. Then waste of over processing. So many of the times we keep on over processing like this. You look at a picture in front of you on a slide. It is raining heavily, still he is watering the plants as a process. So we keep on modifying the slides. We keep on modifying the reports. Too many checks for one of the document like that. So endless refinements, redundant approvals, spatial adjustments for equipments, etc. are waste of over processing. Okay. Then waste of inventory. So if the output of all the stepwise processes is not matching, it is likely that it will create an inventory in the processes, or inventory at each step of the processes. We looked at an example of a value stream mapping. So stamping was only a one second job, but the atom remains in the queue for 5 days, which is what is mean by an inventory in the process. So it has to be uniformly with the minimum inventory at each station. That is what is uh, expected as a lean process. So any retention of product, resource, information in excess of customer process requirement, this is what is called as an inventory in the setup. So waste of transportation. So when waste of transportation basically means your design of the setup is not right. Then probably you have a warehouse located at long. From a process plant, you ship that to an warehouse, and from that warehouse to warehouse two, and then to a dispatch. This is one of the example of an waste of transportation. So waste of intellects, that is what is called as an eighth waste. So the proper person or a perfect person at perfect job should be an ideal way. So any who is not perfect for that or is an intellect waste. That is what is emphasized in Japanese concept. And one who is fit for that job has to be given that job, and that is very important for an employee engagement perspective, also for an organization. Okay, so there are many other delay areas where you can understand or you can identify on non-value added activities is delay, customer waiting for service, duplication, having re-entering a data, repeat details, unnecessary movement, unclear communication, incorrect inventory, out of stock, opportunity lost, or errors in the processing. These are few more examples. Then there is a concept which is called as an 5S philosophy. So, shall we take a break for 10 minutes and again reassemble at 7? Himanshu? Hello? 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 Okay? Can we start?
Yes, sir.
Yes. Moving on to a next methodology, which is or philosophy, which is called as an 5S philosophy. So it is also very popular in Japanese, in Japan, rather originated from Japan. And this is a focus on effective workplace organization and standardizing work procedures. So again, as it name implies that 5S means there are five steps in the process with starting from S. So the method is converting it to English. It is called as in sort, systemization, standardize, shining, and self-discipline. While the Japanese names are like this. So what is being done in a sort? So sort is basically sort and set in order. So what is being done in a sort is identify what is not non-wanted. So segregation required for usable, reworkable, and absolute items. So this is being regularly used, this is being occasionally used, or this is absolutely remote times it is being used. So if you go to your mummy's kitchen, it is a good example of an 5 year structure or implementation of an 5 years methodology, where you will see all those utensils which are regularly usable are kept nearby, and the utensils which are rarely used are kept on the loft somewhere else. So this is what is a segregation. Dispose of the unwanted items and clearing of the walkways. So that is what is called as a sorting or clearing. The next step is systemization or set in order. So basically the steps called often PIP. So place for everything and everything at its place. So the long form or short form is PEEP, PEEP. Place for everything, identify place for everything and keep everything at its place. So use labels, color codes for identification, filing, drawings to facilitate retrievals, or plan storage with easy accessibility. That is what is called as a set in order or standardizing. The third meaning is actually standardizing is and develop standards. Establish checking procedures using 5Ws or 1H. Create visual controls. If something like in a detectability, what we do, we improve the detectability many times. So we get an early warnings that this temperature is shooting up, and then this is what is likely to happen. So create an visual controls. So probably have something which any human person can be detecting, can be able to detect that this is wrong. That is what is mean of an standardization. Uh, Means to expose problems. So action speaks louder than the words. Then shining. In a Japanese concept, when people come to their workplace, they themselves clean everything. So that is what is mean of a shining. They even will clean their desk. There is no housekeeping person which is assigned in an organization. So if they are working on some machine or equipment, or if you own a car, probably the concept in Japan is they themselves will clean the car, so that they understand whether is there anything missing, or is something leaking, or which is going out, or indicating any problem, so that they can identify a root cause of a same. So the concept here is listen, look, and feel. So listen for a loud noise, vibration for feel, and look for anything which is abnormal happening at the shop floor. So the very important, once you have put everything in place, it is very important to have a self-discipline. Now, if you recall the second step, uh, means a PIP, place for everything and everything at its place. But generally what we do in our days, that we don't have self-discipline to maintain that PIP, or we keep that at the same position. So it is a self-discipline by all the individuals in the organization to follow what has been decided, and to carry out regular audits on that, self audits by third party audits or second party audits, to understand if something is going wrong. That is what is the understanding of an self discipline. So basically it is not generally a improvement methodology, but it is called as a way of life. And if the 5 US is implemented, the things at the shop floor are neat and clean. And if the things are neat and clean, definitely there will be always a business results. But when we in Six Sigma, we call it or we look at it as a bigger umbrella. If suppose uh, based on the metric which is and Six Sigma project, if the 5 US is required to be done, you do 5 US in an organization or a workshop, so that my Y improves, my CTQ improves. If it is only a feel good factor, then generally don't go for an this type of improvements. That is what is emphasized in Six Sigma. Okay, so the through 5 years, remove all 3D. It is dangerous. What is dirty in the process? What is dangerous in the process, and what is difficult in the process? As you see, dirty is which is not clean. Dangerous is with the risk of an accident, etc. So you remove those dangerous spots, and you also make your processes easy, or make some equipments available to lift this heavy load, which is difficult. So address dirty 3Ds, that is dirty, dangerous, difficult. That is what is. So these are the examples of an 5 US, how it is before the 5 US and then after 5 US. So everything is labeled and kept at its place. So everything is perfectly marked, barricaded with yellow strips. So like that. This is also how you have to keep the tools. The one of the major advantage that if you lose some spanner, you will immediately come to know that this spanner is missed out, etc., or some tool is missed out. That is what is the biggest advantage. And if they are all kept in a toolbox, it may happen that you will take more time to identify or keep on searching for that equipment, while here it is easily available on a display, so that you can pick it up and keep it there. So the next one of the tool, which is called as an Poka-Yoke. So Poka or Yoke means to avoid errors. So avoid errors to travel in the process. So means make your process mistake proof for make your process step mistake full. So this is what is emphasized here, is if it is between 30 to 50, it is good. If it is not, that you display it like red. And if it is bad, then you have an alarm or something like that. That is what is called as a best Poka-Yoke. So if it is bad, you don't only mark it as a red. This is a visual display of what is bad. But if you put an alarm for that, then you will come to know that this thing has gone wrong. That is what is an Poka-Yoke. The more common examples is if you open the lid of an washing machine, your washing machine stops. So that is what is one of the Poka-Yoke. Now there are a lot of Pokayoke being done in a automotive industry. So if your headlights are on, probably it gives you beep 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 signal. Now the cars are being designed that if you don't put your seat belt, the car won't start. That is also one of the Pokayoke to ensure the safety of an passengers or drivers. Okay. So this is what is Pokayoke. Then one of the tool which is also called as a spaghetti diagram. So how you are design your tool room or office or layout at your factory is also important. So the spaghetti diagram is just drawing a movement of an people and etc. And from understanding from that how you should be designing your work cell or office or workshop etc. That is what is spaghetti diagram. So these are the basic tools to improve the process. It's done in an analyze phase, and now we are moving to an improve phase where it is a combination of both quality tools as well as a lean tools. The questions what we ask in an improve phase is optimize the critical access. So if suppose I understand few parameters which has got a relationship with my Y, I optimize them, then I establish the controls for that, and then do an hypothesis testing to really ensure that whether my process has improved statistically or not. These are the 3 steps. So perform design of experiments if required for parameter optimization. Then define operating tolerance for potential systems, means what we have been saying that control excess. So we are defining the operating tolerances for excess, conducting a pilot study, and then having a potential solution developed. That is what is an improve phase. So if we implement those actions, now if you look at this, the process earlier was at 20, I improved it to 30 with lot of variation. And if this is another example, the process was at 20 and improved it to 30. Now what is mentioned or what is shown in a below picture is what is expected. And that is what we ensure by using an hypothesis testing, that my improved process is statistically different than my earlier process. We generally go by an averages. So average has improved, we are happy, or our bosses are happy. But that is what is not an intent of an Six Sigma project. The intent of an Six Sigma project is also about the probability of the event, so that we should be predicting the output. And if we have the outcome which is distinctly different than my earlier process, probably we will be predicting the output for tomorrow. And that is what is expected out of an Six Sigma project. That is what I mean by an statistical change in the process. So we do it using hypothesis testing, which is called as a 2 sample t-test. So we test it using a 2 sample t-test, and if the p-value is less than 0.025, we say that the process has improved, and you can understand that also using a box plot. So this is what is hypothesis testing. The next step is, or the last step is a control phase. In a control phase, we determine what is a new process capability. That means my process has already improved. Now, what is my new capability? So when I took up a project on a 0 to 6 scale, my process capability was 2. And if I improve the process, how much capability has gone up? Whether it has, how much sigma level it has improved. And if you are improving even a 0.2 or 0.3 sigma level, that there is a huge number of defect reduction. And the attempt or emphasis is to reduce the defects so that you improve the capability of the process. Then the next is how can I sustain this improvement? So doing it good for a limited period is not sufficient. So how can I sustain this improvement? That is what is my control plan, or what is my control system that I am going to ensure to sustain this improvement. That is what is a control phase is. And what is the benefit, and is that benefit validated by my finance or my process owner? That is what is being checked. So the whole purpose of an control phase is hold the gains. So once I improve, it is important that I should have a perfect plan and perfect steps and perfect metric to hand over that project to a process owner, and I should hold those gains. So what is important of for an control phase is document change in procedure, use data to monitor performance, whether I have really improved and it is sustaining. Be proactive in implementing for a potential problems. If suppose something is going wrong in a control phase, be proactive. You should understand that and then improve it. And assigning specific responsibilities for performing the work. So at the end of the project, you will come out with an action plan, and then you will clearly write down who is responsible for maintaining this. So you will say plant manager, production manager, something like that, or site shift engineer who will do this responsibility. That is what is a part of a control plan. When we initially start our project, the involvement for a define and measure phase, the involvement of a project team or a project leader is very important and is very high. Once we move from that project define measure phase to an analyze phase, our operating team is also equally involved in the process for an identification excess, etc. Once we identify a vital excess and implement them for an improve phase and then control it, our involvement of the improvement team goes up and the involvement of the project team goes down. That is what is an expected one. Means as it moves toward the control phase, the project team is handing over the project to the operating team with the demonstration of an improvement. So in a control phase, there are various control charts are being used to monitor the process. So the types of various types of control charts are being used. Depends on the what type of data is there for the process. That is what type of CTQ or the CTQ is of what type of a data. So if the CTQ is of a variable or a continuous data, the control charts used are different. And if it is an attribute or discrete data, the charts used are different. So if it is a continuous data, so how much is the volume? It is low once in a day, then it is probably a individual and moving range chart. And if the volume is high 4 times a day, probably it is called as an X bar chart. So we will take an average of these 4, that is what is called as an X bar. If it is an attribute data with a constant sample size or non-constant sample size, if the sample size is not constant, then what it looks at, whether it talks about the defects or a defectives. If it talks about the defects, it is U chart. If it is talks about the percentage defect, probably it is P chart. And if it is a constant lot size, then if it is a defects, then it is a C chart, or percentage defective, it is then an NP charts. So there are various charts which are being used to monitor the process in a control phase. The idea is to understand whether the process is in control or not. So it depends on the type of a data type in a CTQ. So to monitor that process, there are certain rules which have been stated in statistical process controls. So typically you have a central line which is your average, And on the average, if you have +1 standard deviation, +2 standard deviation, +3 standard deviation, so rather I will say if you have an average and ±1 standard deviation is called zone C, ±2 standard deviation is called zone B, and ±3 standard deviation is zone called O. This is a typical process of ±3 standard deviations. So if there are certain rules for this. So if you look at this, anything beyond your zone A, which is called as an the process is not in control. If such type of incident happens when you are monitoring a process, you can go back to a process and identify a reason for this. Please try to understand whether it is an assignable cause or a common cause. If it is a common cause, then it is a matter of concern for your project. What is the difference between a common cause and assignable cause? The assignable cause is that you know the reason for that. Now we will get an example. When you appear for your general exams like midterm, term, or any unit test or any exams, your score remains average 75 with variation from 70 to 78, like that. Now in a particular exam, you score only 50. Uh, and if you go back and analyze that reason, when you scored 50, you are having a fever for 2-3 days in earlier. So your score was 50 because there was an assignable cause that you was not well and you was having a fever. That is what I mean as an assignable cause. And all of a sudden you score 55 or 60 and you don't know any reason, then it is called as a common cause variation. So when a reason is called assignable cause, if you have an action plan ready to eliminate that assignable reason, then it is called as an assignable cause. So there are two different causes for a assignable cause and a common cause. So if your process goes out of limit, you go and understand whether it is assignable or common cause. If it is assignable, you can have an action plan to remove the cause, or you treat that as a common cause and look for a potential excess in the process. The second reason or second point rule to call your process not in control is having all the 9 points on the one side. Now, if you look at this 9, 3, where it comes from, this comes from like number 9 comes from a probability of the event. So, looking at the probability, we calculate a probability, and when it becomes 9, that if all these 9 points are on one side, probably the process is not in control. That is what is the meaning. Okay. Then the rule 3 is 6 points steadily increasing or decreasing. Here I have shown decreasing. The 6 points are steadily decreasing, or it can be increasing also, but they are in the same direction, all the 6 points. Then rule 4 is 14 points in a row in a zigzag motion. Means up and down, up and down, up and down, like 14 times. This is rule 4. Then rule 5 is 2 out of 3 is out of zone A and beyond. Okay, so 2 out of 3 are in zone A, 2 out of 3 are in zone A, 2 out of 3 in zone A. So if you have 2 out of 3 points in zone A, probably your process is likely to go out beyond 3, or your process is not in real control. The sixth rule is 4 out of 5 in a row in a zone B. So out of your 5 points, 4 points are in a zone B. Okay, that is also indicating that your process is not in control. And rule 7 is your all 15 points are in a zone C, Uh, that is, uh, actually, you will feel your understanding may be like that. You are in good control of the process, but what statistics or statistical process control suggest that if you have 15 points in zone C, probably you have not calculated your plus minus sigma or your limits correctly. So you go back and based on this historical data, calculate your limits again and have a recalculation for zone C, zone B, zone A, and then look at the graphs again. That is what is meaning of an rule 7. So this is how you can monitor the process. Rule 8 is 8 points in a row on both sides of the central line. So 8 points on the means zone C के बाहर 8 point है. That is what is this rule is. So all these rules are indicating that your process is not in control, and if your process is not in control, you have to go back to a process and look at an assignable cause or control and then work on the same. Once you improve the process, you have to write down your control plan very clearly. So this is one of the example of an control plan. What is your vital X? So probably I show you a project from a polyester filament yarn, and we identify 4 X's there. So what are those X's? What is the action taken on them? What is controlled means what you are actually controlling. So when we say we are reducing stability, e.g., ethylene glycol kg per metric ton. So what you are actually doing? So we are reducing the pump RPM. That is what is controlled. Then what is control type means is it a standard operating procedure or standard operating condition? So probably it is a standard operating condition which is set. So this is standard operating condition which is a control type. And what is the control method? So controller output is being adjusted for an pump. That is what is the meaning of an control method. And who is responsible for that? Has to be clearly written down. That is what is called as a control plan. And with this control plan in place, you have to hand over this control plan to a process owner. That is what is exactly the project completion is. If this control plan is not handed over to a process owner, probably he will not know what is to be done if something goes off. And your project gets completed only after you handing over this control plan to a process owner. Now, this is how you can monitor it. This is what is a before chart, and this is how it is an after chart. So probably there were 3 exceptions when it was at baseline, and in a improve phase or a control phase, there is no exception. That is an exception on the lower side, but it is a lower the better function. So this type of exception is always welcome. But it is very important to understand because this is a new entitlement in the process. You need to understand why this particular point has occurred. What are the parameters? You can go and have a correlation analysis to understand why it was good that day for a next process improvement step. So we looked at various tools during this process. What is Pareto analysis, stratification, correlation, then linear, non-linear. Actually, this we are not covered, but these are the various tools which are being used. I have summarized them as in tools. These are the quantitative tools and these are the qualitative tools. Brainstorming, cause and effect. So what is quantitative tools? The quantitative tools is always supported by numbers. So you make an inference based on some numbers available, where qualitative tools just help you to give you an idea about how to solve the problem. So if I look at an YY analysis is an qualitative tool. But if I collect the data at each Y step or analyze it, then it becomes an quantitative tool. That is how it works. So if you look at Six Sigma is not a cure for everything. It cannot compensate for a bad management strategy. It cannot substitute the subject matter expertise. It is not a resource item like capital. It is a methodology that, if properly deployed, will bring about the positive results for any process, and which is what is important for an stakeholders, plant trades, for a business. So one of the very key and important point for you, that this will be helpful for you throughout your career. You can practice this. It is not like that you can learn swimming in a textbook. So the swimming has to be actually performed in a swimming tank. That is how the I have explained you the steps. But when you join any organization, it is very important to follow a proper method of any improvement, proper steps for any improvement. And if you do it, uh, you will be always get noticed in an organization. And basically, we generally talk about I am a problem solver, but how you solve problem, that is most important. So this is what is an methodology which will help you to solve the problems. So Six Sigma is not something else that you do. That is what you should be doing it throughout your career, and it will definitely help you. That is what is my confidence is. So if we look at the various roles and responsibilities of the people involved in Six Sigma, so probably sponsor, who is a senior person in the organization, who will say go and do it. Like if suppose any organizations want to deploy in Six Sigma, any industry wants to deploy, so there will be a works manager or a plant manager or a site president who will say that yes, we want to do it. Then the champions are the process owner, who are actually beneficiary of these projects, improvement projects. And the project leader, green belt or black belts, those who are leading the improvement teams, they are called as a project leaders, green belts and black belts. The again, it is an always a teamwork. So they will always select the team members. And in some organization it is also called as an yellow belt, but we can call it as an Six Sigma team members. And there is a master black belt who is in the organization generally to coach or guide or to mentor. He is a supporting hand for champions and process owner to identify the projects, and then help or handhold the project leader, green belt or black belts, to actually complete identification X. So his rigor or his emphasis is following up steps, not only the results. While champion and sponsors emphasize is only on the results, while master black belt is keen on whether you have followed the rigor of Six Sigma or not, is also important for it. So that is how the master black belt works. Any questions on this? So you can, if you have any doubts, any clarifications required, you can reach out to me on my Gmail or my phone number. My phone number is 99675842122. I repeat, 99675842122. Or my Gmail address is sharadchandra.d.karve@gmail.com. Himanshu